Throughout the year, various reasons prompt companies in the oil and gas industry to inspect subsea pipeline, tie-ins, and state-mandated mitigation reefs. The Gulf of Mexico alone is home to approximately 45,000 miles of pipeline that accounts for 35% of the oil production in the domestic U.S. and 20% of its natural gas production. Combined, these figures represent $30 billion of oil and gas flow annually. Government regulations, Gulf Coast storms, and general maintenance force the industry to inspect approximately 38,700 miles of pipeline each year. To date, it's always been extremely costly and time-consuming to inspect pipeline using conventional inspection methods. But new technology dramatically reduces those burdens. Introducing the NovaRay, the next evolution in oceanic ROV technology from Marine Exploration Services. Significantly less expensive and 7 times faster at inspecting, pipeline owners who utilize the NovaRay can expect to operate much more efficiently and cost-effectively year after year. Now, let's take a closer look at how the NovaRay can offer such impressive numbers. First and foremost, NovaRay's modular design makes it highly scalable, easy to transport, and simple to deploy, operate, and service. Its small footprint makes it an ideal solution for inspecting subsea pipeline and tie-in structures, as well as state-mandated mitigation reefs. NovaRay's exceptional maneuverability is a byproduct of its patented arcuate design. The vehicle's ability to be controlled while in tow makes it exceptionally stable, and its ability to fly into position as needed provides for faster, more accurate data capture. Capable of gathering sonar and video in depths up to 1,000 feet, the completely configurable NovaRay can be outfitted with advanced tracking and video equipment, forward and side scan sonar devices, and even lasers for relative visual positioning and precise altitude surveys. Working in unison, these features allow for the most thorough and accurate one-trip data capture in the widest range of subsea conditions. Now, let's take a look at the NovaRay in action during various subsea inspection activities. Given the small stature of the NovaRay, deployment of the vehicle is relatively simple and can easily be handled by 2 men. Once the vehicle is submerged, the pilot guides the ROV to the proper depth and begins to tow the NovaRay along the pipeline. Traditional inspection equipment must be retrieved from the water and redeployed at each site, and oftentimes overlooks potential pipeline problems. However, the NovaRay operates under a controlled tow and has the ability to stop and maneuver under its own power. In fact, the NovaRay can maneuver up, down, left, right, backwards, and forwards, giving pipeline owners more accurate real-time data. Look at the incredible maneuverability of the NovaRay as it stops along the pipeline route and begins to free fly to get a closer look at a tie-down. Once the detailed inspection is complete, notice how easily the NovaRay flies back into tow position without having to be retrieved and redeployed. This saves valuable time during the inspection process. During NovaRay operations, thoroughly trained technicians visually inspect the subsea pipeline and other structures, while the highly sophisticated video, sonar, and laser visual positioning work in unison to capture the data. Best of all, NovaRay pilots are highly trained ROV operators as well as divers, so if an issue arises during remote inspection, a physical inspection can immediately take place if the depth allows for human intervention. Now, watch closely as the NovaRay enters the murky waters of a thermocline. Video images become limited, but data is still being captured by the vehicle's front and side sonar equipment. While traditional sonar torpedoes must be dragged and cannot accommodate video, the NovaRay offers the best of both worlds. This dual functionality, coupled with NovaRay's exceptional maneuverability, allows for the most thorough and accurate one-trip data collection, irrespective of the subsea conditions. As the NovaRay approaches a pipeline rock pile in a shipping channel, Notice how easily it maneuvers up and over the rock pile as needed. For a closer inspection of the pipeline cover, the NovaRay simply flies over the area in an S formation so technicians can fully observe the pile for exposed pipe or cover misplacement. Observe a conventional sonar torpedo as it approaches a rock pile. A lack of control over the torpedo can cause it to crash into the rock pile or be swept off-site, damaging the equipment and causing costly inspection delays. Now, watch as a NovaRay configured with lasers hovers in a precise position above the pipeline to capture critical measurements of zinc anodes. The lasers are preset 10 centimeters from dot to dot. If the NovaRay changes altitude, the lasers get closer or farther apart as needed. Notice how the NovaRay lasers are used to show the effects of anchor scarring and sea life at a precise altitude. And one of the most useful and cost-effective applications of the NovaRay is its ability to thoroughly inspect subsea tie-in structures. The vehicle's small size and exceptional maneuverability allow it to fly up, down, and around the tie-in structure to remotely inspect and capture data on individual valve damage, corrosion, or potential leaks. Other applications of the NovaRay include inspection of state-mandated mitigation reefs, anchor scarring studies, and assessment of machine-laid pipeline. Given all of its unique features, advanced capabilities, and onboard technologies, the NovaRay solution is undoubtedly the most cost-effective and thorough inspection tool available in the marketplace today.